let's see another problem based on mathematical induction, that is a plus d plus a plus 2d plus so on up to n terms is equals to n by 2 into 2a plus n minus 1 into d. So well, this question is a bit familiar for you people because it is representing as some of the terms of the AP arithmetic progression, right? So let the given statement be s of n is equals to a plus d plus a plus 2d plus so on till a plus n minus 1 into d. That is the nth term of the AP arithmetic progression, which is equals to n by 2 into 2a plus n minus 1 into d. So we have to prove that this statement holds true for n belongs to capital N. Step 1, let's take that. To prove the statement s of n is true for n is equals to 1. So we have to check for n is equals to 1. So simply for taking for the first term, n is equals to 1, only one term will be there. So a, you can take it directly, or you can also just substitute in the nth term of the AP, that is a plus n minus 1 into d, as n is equals to 1. So s of 1 is equals to a plus, instead of n you can substitute 1, that is 1 minus 1 into d, which is equals to a plus 1 minus 1 into d. 1 minus 1 is 0, that is simply a. Now you have to check on with the RHS. RHS, instead of n you substitute 1. You will be getting 1 by 2 into 2a plus 1 minus 1 into d, which is equals to 1 by 2 into 2a, which is equals to 2a by a, which is equals to a. Okay, so now you have checked, right? You are getting LHS is equals to RHS. Now this statement is satisfying and it holds true for n is equals to 1. Now we have to assume that the given statement s of n is true for n is equals to k, that is a plus d plus so on till a plus k minus 1 into d is equals to k by 2 into 2a plus k minus 1 into d. Now in the third step we have to prove that the statement is true for n is equals to k plus 1. For this we want k plus 1th term. So simply in the in the kth term you have to substitute k value as k plus 1. So on substituting you get a plus k plus 1 minus 1 into d, which is equals to a plus k into d. Plus 1 minus 1 will get cancelled. Okay, now we have to add this term, that is a plus kd, on both sides of the equation 2. We'll get the sum of k plus 1th terms, okay, which is equals to a plus d plus a plus 2d plus so on till a plus k minus 1 into d plus a plus kd is equals to k by 2 into 2a plus k minus 1 into d plus a plus kd, which is equals to ak plus k by 2 into k minus 1 into d plus a plus kd. Now you separate a terms, okay, aside and kd terms aside. On taking that we'll get a k plus a plus d. Take d as common, you will be getting as d into k plus k by 2 into k minus 1. Now on separating it, this terms, that is k by 2 into k minus 1, you will be getting it as k square by 2 minus k by 2. So this term in total you can just take a as common, so you will be getting it as a into k plus 1. So now we are getting something in terms of k plus 1 and we need the RHS part in terms of k plus 1, okay, in order to prove our statement. So we got we got as a product of a into k plus 1. So this is settled. Now let's simplify this, that is d into k plus k square by 2 minus k by 2. So k minus k by 2, which is equals to plus k by 2, we get it as a into k plus 1 plus d into k square by 2 plus k by 2, which is equals to a into k plus 1 plus d into k divided by 2 into k plus 1, which is equals to, now we have to take k plus 1 by 2 as common because we want the term to be as n by 2, right? On RHS part, we want the term to be as n by 2. And why we want it like that? Because our RHS part is in terms of n by 2. So something in terms of k plus 1 by 2 we want. So k plus 1 by 2 we got it into, we have to simply multiply with 2a, 2 into a, because here there is no 2, right? So for getting 2 over here, we have to simply multiply and divide with 2. So we got 2a plus d into k. Now here we have 2, right? So we can simply take common as k plus 1 by 2, whereas here we don't have 2. So here we don't have 2, right? So we are taking 2 into a plus d into k. Now this k can be expressed as k plus 1 minus 1, okay? Now here as you can see that this is resembling as n minus 1. So we got it as equal to k plus 1 by 2 into 2a plus d into k plus 1 minus 1. Now this is the perfect sum of k plus 1th term in terms of k plus 1 of the AP. Now we got the solution in terms of k plus 1. Therefore we can say that the given statement is true for n is equals to k plus 1. Therefore the given statement is true for n, for all n belongs to capital N. Hence proved. If you have any doubt, please do comment in the comment section. Thanks for watching.